So, David, some of the general, topics today are basically asking some of the questions that we touched on a little bit in our previous episode with you. And they're also questions that we are getting more and more and more from our clients now. But I want to talk a little bit about the latest developments in AI, talk to you a little bit about standards, regulations, and governance. And then I also would like to talk to you about concerns for human creativity and critical thinking, which is a major area of interest for me. And then I'd also like to explore with you questions regarding AI and education. I see a lot of what we do at Nestell Associates is really based on effective education. So those are some of the topics I'd like to cover with you. But before we dive in, I would like to get some thoughts on, and I may be opening up a can of worms here for our conversation, but I wanted to ask you a lot of questions in the spirit of two ideas. And the first one is, so I have a book here, David, and I think you're familiar with this, but it was actually published in 2023, and it was by two gentlemen, Dr. Job Landgrebe, I believe I'm pronouncing his name correctly. If I'm not, I apologize, and Barry Smith. And just so our listeners know, Dr. Landgrebe is actually going to be on our podcast here, but they did write a book in 2023. So, David, if I may, and give me just a moment, but I want to share with you what it says in the book. And I'm working my way through this book. I haven't finished it yet. But on the back of the book, it says this: the book's core argument is that artificial intelligence that could equal or exceed human intelligence, sometimes called artificial general intelligence, is for mathematical reasons impossible. It offers two specific reasons for this claim. One, human intelligence is a capability of complex dynamic system, the human brain and the central nervous system. And two, systems of this sort cannot be modeled mathematically in any way that allows them to operate inside a computer. And then they go on just briefly here. In supporting their claim, the authors marshal evidence from mathematics, physics, computer science, philosophy, linguistics, and biology, setting up their book around three central questions. What are the essential marks of artificial intelligence? What is it that researchers try to do when they attempt to achieve artificial intelligence? And why, after more than 50 years, are our most common interactions with AI, for example, with our bank's computers, still so unsatisfactory? So, David, I'm putting you on the spot a little bit here, but I would like, maybe if you have an initial response to that, great. But maybe as we go through some of these questions I have for you today, if you can maybe do it in the context of keeping this idea in mind.
Sure.
So before we move on, I'll let you have the floor in response to that.
Yeah. So, I mean, their position is it's not uncommon and it's very well defended. And so what I want to do is I'll first start by validating part of their argument. And so this is something that I bring up often, is that math is truly only ever an approximation of the physical world. That I agree on. However, there's several fundamental flawed assumptions of their argument. And I really kind of only need to unpack one of them, I think, and that is the assumption that the human brain is the only way to achieve intelligence. There's not really any evidence of that. I mean, there's multiple animals on the planet that have various levels of intelligence. So we know that neural structures with various form factors, various evolutionary paths can all achieve different levels of intelligence. But then also, just because the substrate is different, and so by substrate, I mean, whether it's running on neurons or silicon chips or whatever, it's still just processing information. If you take a materialist approach and say, okay, all that's happening here is matter and energy is doing something, right? If you remove the idea of like maybe there's an immaterial soul or the mind is separate from the body, if you take a physics first approach, which it sounds like they did, then it's still just information propagating across a physical substrate. And so from that perspective, yes, it's unlikely that we could ever have a perfect simulation of a human brain, but there's not really any evidence that that is required to achieve intelligence. And there was a talk given by one of the members of OpenAI back when he was still at Stanford, I think. And he said, these things only seem to understand. And it's like, well, they seem to understand really well. And they seem to be able to write code. They seem to be able to think. And you could say the same thing about people, or, the people seem to understand. And so there's really this kind of normalcy bias. There's these two phenomena. So one is normalcy bias, which is, this is all I've ever seen in my entire life. So therefore, I can't really imagine things being different. And that is, I mean, to be fair, no one alive today has really lived through the kind of revolution that is possible with artificial intelligence. And then the other one is human exceptionalism, which is rooted both in just our basic psychology and our basic experience. We're the smartest animals on the planet, but it's also rooted in cultural paradigms often spoken to in religion. For instance, the Bible says we are created in God's image and we are special. Now, when you divorce from that idea and you just say, okay, let's take a look at it just from a biological perspective, from a physics perspective, there's actually nothing really secret about us. There's no magic, there's no special materials that go into, our brains or whatever. And so when you understand it, and some scientists say, oh, well, think of us as, biological robots. That's a little bit reductive, but at the same time, there is some validity in looking at, from a first principles perspective, what actually goes into the information that we take in, the processing that happens internally, and then the behavior that we output in the world. Because that model of input, processing, and output is kind of the best way to look at how we handle that information. So I don't personally buy the argument that it is mathematically impossible to achieve human-like intelligence or even superhuman intelligence. Yes, the inner workings will be different at a fundamental level, but really when you look at the objective, the empirical behaviors that result from this kind of intelligence, I don't really think that their argument will stand up to the test of time. Of course, time will tell.
Well, great. Thanks, David. And so my second question for you to kick things off here is, it's a bit futuristic, but I'm going to go for it. But, imagine a world in the near future here where you can drop a piece of AI code within your current ERP platform or within your organization on a tech stack, and it will build a new system around your core system or just start from ground zero. In other words, you won't need a new ERP system, or maybe ERP vendors, that world could change dramatically here in the next few years with ERP vendors even going out of business. What's your thoughts on that idea?
Yeah. So, I mean, the kinds of platforms that we're talking about here are some of the largest and most sophisticated platforms that humans have ever built. And so the time that it will take to fully replace them is going to be a while. So from a technologist perspective, first, I would imagine all these existing platforms, whether it's Epic, which is more of a medical, not really, ERP, but it's a similar large platform. They're going to start integrating AI, whether it's Oracle or SaaS or other ones. SaaS has been one of the world leaders in AI, but they'll start integrating AI into these platforms. But for what you're talking about, kind of imagining what's the next generation of these platforms, what could that look like, if you built it from the ground up. And so kind of a pie in the sky thing that I anticipate will happen eventually, could be within the next 5 years, could be longer, is what's called polymorphic applications. And so a polymorphic application is something where you have an engine that can build other applications. And so the primary thing that I suspect companies are going to be paying for is not the applications, but the thing that builds applications. Kind of like the replicator from Star Trek, except the replicator for software, right? It's like, hey, computer, I need a software platform that handles X, Y, and Z middleware tasks and automates these vendor integrations, and it'll go off and do it. And oh, by the way, Amazon, Microsoft, Google, all of these big shops are working on that kind of software. The very first prototypes of that kind of software, in the background, they're called agents. And so we're going to have these agent platforms, which are going to be able to talk to any API. And when I say they're going to be able to, they already can. This is part of the testing cycle, is not only being able to talk to an API so that you can integrate into any other platform, but then they can also think about what resources do they need? What information do they need to carry out a task? They can do certain levels of planning. And since we're only at the beginning of this technology, it's only going to get better. Now, we're a ways off from those being commercially viable, commercially ready. Microsoft actually interviewed the researcher at Microsoft, Dr. Chi Wang, who is leading the charge there with what's called AutoGen. So they just released AutoGen version 2. Again, this is still just in the tinkering phase. It's not something that I would recommend anyone deploy that has any impact on your bottom line yet, but it's coming. It's a preview of what's coming. And the cash incentive, the impact to your bottom line and your top line, is going to make these kinds of technologies and their successors absolutely imperative to adopt sooner or later.
So, David, let me ask you a follow-up question here then. N&A, Nestell Associates, and this is a topic of mine that I just really quite passionate interest, and that is the idea and the relationship between people, processes, and technology, right? And as we know in this current day and age, and I know that can be a bit of a buzzword or a bit of a cliche, but it's true. To successfully implement large scale enterprise software across an organization and to do that effectively and efficient, it really comes down to effective processes in terms of maybe PM tactics and understanding internal processes, but also the right organizational culture and the mindset for the change and, the advocates for such a significant change. And then, of course, it all starts with the foundation, which is the technical system, right? The technical cornerstone in terms of features and functions that allow you to support your people and processes. How do you see, back to my futuristic question here, where you just drop a snippet of code on a machine and it generates a new system? How do you see that dynamic between those three pieces changing here in the next 5-10 years?
So one analogy that I like to use is telephone operators. So at a certain point in time, for all the telephony companies, you had to have, switchboards, telephone operators, just rooms full of people manually making connections. And that was not sustainable. It wasn't sustainable. It wasn't scalable. There was simply just not going to be enough telephone operators. And so what did they do? They had their scientists and engineers go and invent an entirely new approach. And so this is the kind of creative destruction that we will probably expect to see, where a lot of people, and I get this kind of feedback a lot, where someone's like, oh, well, it's not really possible to automate away my job because I do X, Y, and Z, and I have to know, 8 million things, and I know a bunch of people. But the thing is, think about how email could replace much of the postal service. And so whether it's horses and trains and boats, there's a whole raft of infrastructure that you just no longer need when you switch from post to email. Likewise, there's a whole lot of infrastructure and a whole lot of people that you just don't need because you replace it with a fundamentally different approach with the plain old telephone systems and digital voice over IP. And so this is the kind of what's called a saltatory leap that we should expect as AI systems get more and more developed and sophisticated, is they'll just preempt the need for a lot of current jobs. Now, of course, the big question is, will this create new jobs? In the same way that, we don't have telephone operators anymore, we don't have typing pools anymore, but we have plenty more office workers. But the thing that I really kind of think about is, okay, if these AI agents and these AI tools get that much smarter, why would that job go to a human when the machine might be cheaper, faster, and safer than a human? So that's kind of one of the big things to keep in mind. And we're already seeing some evidence across the board headcount reduction in some departments. So out there in the news, there have been call centers that have replaced a huge chunk of their staff, 90% reduction by switching to AI-enabled chatbots. And in some cases, the CSAT scores actually go up drastically over, humans. And so now it's not even a matter of retraining humans. It's this new approach subverts even the need for a human in that role, which that's good for the bottom line. That's good for investors. Humans are expensive to employ, but that similarly causes a lot of anxiety and resistance in employees. There was another study, I think this one was actually by MIT, that showed that the more employees use AI, the more they fear for their job. Because over time, as employees use these new AI tools, they realize, wait, I'm not using my brain as much. Why am I here? And so they kind of see the writing is on the wall. And so there's the kind of two primary reactions: is one, skepticism, and then two, fear or anxiety. It's kind of, two sides of the same coin. And so from a people, processes, and technology standpoint, the technology sells itself. It is super compelling. And once you find that use case where it's like, oh, hey, it either makes us two times more productive or it reduces headcount, whatever, it has some direct impact on the bottom line, the technology sells itself. It would be like, imagine you have a motor pool and you say, well, actually, we're going to go back to horse and carriage. That argument just doesn't make sense. And in many cases, for companies, whether it's, small entrepreneurs as small as myself to SMBs and enterprises, it's kind of like once you go to AI, you never really go back. And so the technology sells itself. The people, that transformation, I think, is going to be one of the most difficult and one of the most painful aspects. Right now, unemployment is still really good in terms of it's relatively low. But, as we see things transforming into the future, it remains to be seen as to whether or not these jobs dislocations will result in more employment elsewhere. And then, of course, the processes themselves, kind of implied in all this, is you find a fundamentally different process to achieve the same or better result, is kind of what I'm talking about with this wholesale rip and replace, in terms of deploying new systems that turn your business velocity up to 11.
Well, interesting. Thanks, David. Could you maybe give our listeners an overview of the latest developments in AI that you find most exciting or transformative?
Yeah, so there's two right off the top of my head. So the first one is a video model by OpenAI called Sora. And I don't think that's an acronym, it's just Sora. So Sora produces, it's not quite perfect video, but it produces high resolution video at 4K. And it's what's called a text to video model, where you just type in a scene that you want, and then it goes off and generates it. And, a few minutes later, gives you up to a minute long 4K, so high definition video of what you asked for, including sound, I think. I haven't had a chance to use it yet. It's still in the kind of private beta rollout. But this technology, and I predicted this more than 2 years ago in my first book, so it's right on time, right on schedule. This technology, for instance, one, is going to be great for marketers, because it's, hey, instead of having to set up, a $20,000 a day photo shoot, you say, here's a few pictures of the product that we're selling, put it on a model, here's a new commercial. Boom, you're done, right? And so that is going to be good for marketers. It's bad for the actors, the voiceover artists. It's bad for a lot of people, but it's good for the business's bottom line. Now, personally, as one of my primary hobbies is I'm a sci-fi author, so I'm waiting another year or two, and then I'm going to translate my novel into a 4K, Hollywood-looking, blockbuster,
Yeah.
and I'm going to do it for less than $1,000.
Wow.
It's really difficult to wrap your mind around the cost differences. Now, the other innovation is Claude 3 just came out. So Claude 3 is the latest chatbot by a company called Anthropic. And so Anthropic AI, they were actually founded by people who left OpenAI because they were concerned about the safety practices at OpenAI. Now, so they train their chatbot with a fundamentally different paradigm. Well, a few fundamentally different paradigms. There's some convergence in the industry as well. But Claude 3 has basically shocked a lot of people. There are a lot of postdoctoral researchers out there in domains ranging from physics to quantum computing and others. And these researchers have given Claude maybe their thesis or their current work, and it is able to effectively help them with their research. And so when you think of okay, someone who's doing advanced physics, someone who's doing frontier mathematics, someone who's doing quantum computing, these are things that there's only a few thousand people on the planet qualified to do that level of research, and they are impressed by this new tool. And we're only just getting started. And so this is a small hint of what's to come in terms of the capabilities of these machines. Now, are there going to be diminishing returns? I suspect we will see diminishing returns, but the people building these things, they say we're nowhere near the plateau. We're still before even the exponential ramp up. So imagine a sigmoid curve. If you haven't seen a sigmoid curve, it's vaguely S-shaped. So it starts low, it ramps up, and then it tapers off near the top.
Yep.
We're not even at the middle of the sigmoid curve yet in terms of what this technology is ultimately going to be capable of.
Crazy. So, David, with AI evolving so rapidly, just in general, how do you see these advancements influencing global technological standards and practices?
So we're going to see a fragmentation. Well, we already are seeing a fragmentation where about a year ago, there was a lot of talk about, just keeping everything open source. And then when all the tech companies started realizing, we're playing with fire now, they started going more closed source. And this is natural. If you have valuable IP, you should, according to business practices, close it up, package it up, resell it. Whatever your secret sauce is, you sell it. The recipe for KFC, right? The recipe for Coca-Cola. You keep that secret and you make money on that. Now, some other companies have taken a different approach where they realize that the AI is just part of the service they're offering, and they're not selling the AI itself. So the biggest example out of Silicon Valley is Meta or Facebook. So they have decided to do most of their work open source. Why? Because Mark Zuckerberg cares more about social media and the metaverse rather than just selling AI for its own sake. So that's kind of the two primary approaches that we're seeing in terms of how companies are approaching this. but you're also going to see a lot of competition and, by extension, a little bit of fragmentation before the market kind of comes back together and consolidates around new best practices. For anyone in the tech space, you might remember about 2 decades ago when Bluetooth was invented,
Yeah.
nobody knew what to use Bluetooth for. People were saying, "Oh, you're going to be able to talk to your dishwasher." Who wants to talk to their dishwasher? Now we know how to use Bluetooth.
Mm-hmm.
Likewise, this area is so new and it's evolving so fast. We don't really know where it's all going to be used. So that's what I mean by fracturing, and then eventually we'll converge on the best practices. But I don't think we're really anywhere near best practices yet.
Got it. And David, you mentioned earlier regarding Claude 3 that folks left due to concerns. And, obviously AI's potentials seem boundless, right? But so do its risk, in my view. What are the latest conversations around AI safety and ethics that you think our listeners should be aware of?
So it depends on who you talk to and who you listen to. If you listen to the establishment, and by the establishment, I mean NIST, National Institute of Standards and Time or Technology, or the government, this is basically just being treated as, same stuff, different day. It's just another new gizmo. And I think that is fundamentally underselling the magnitude of this technology. Now, just because that's what the government and the big players are saying publicly, I don't necessarily think that they know that internally. I think that internally, many of these establishment organizations, whether they're public or private or otherwise international, I think they kind of see the writing on the wall. But most people out there that you talk to have no idea what is happening, what's going on, and what's coming. And so because of this huge, huge distribution in terms of how oriented people are to this technology and this change that's coming, you have to be very careful with your public messaging. And so because of that, it's really kind of difficult to get a read as to who thinks what and what they truly believe versus what they're publicly saying. And I know that might sound a little bit cynical, but it wouldn't be the first time there's been a major disconnect between kind of what's going on behind the scenes, what the conversations happening in closed door meetings versus the public messaging. But again, that's kind of what I mean by the fragmentation that's going to happen as people kind of get caught up to speed with the magnitude of this change. And then the conversation will change. So having been in this space before ChatGPT, there was a huge, huge sea change that happened with the release of ChatGPT. Before ChatGPT, I would talk to people and I was like, "Have you heard about GPT-3?" And people were like, "What are you talking about?" And nobody knew what a language model was, and nobody knew like what generative AI was. After ChatGPT, the conversation changed drastically. And so probably what's going to happen is every time there's a big release where a new product comes out, a new service comes out that will really kind of convince people, okay, we've taken the next big step. But again, it really depends on who you talk to in terms of how oriented they are to the space as to, what their beliefs are. But it changes in steps.
And David, you mentioned the idea of being cynical, and I have to admit, sometimes I find myself being a little bit cynical as I try to maneuver my way through the AI sphere as well. But isn't there an economic factor here as well, regardless of where AI goes in the future, good, bad, or ugly? Isn't there a great deal of money to be made right now from AI? And could part of that be, just talking about ethics and AI control? And I'd like to ask you some questions on governance here in just a moment. But, there's a lot of money to be made right now from AI and AI development and where it could take us. What's your thoughts with that?
Yeah. So a little bit more nuanced take. Generally speaking, technology lowers the cost of goods and services. That's why we do it, right? You use a tractor instead of a bull because the tractor does more and costs less in the long run. Yes, it's more complicated, it's more sophisticated, but if it breaks down, you just fix the engine, you call the mechanic, and it's back up. If your bull breaks a leg, you shoot him and you have to wait a few years or go spend a few $1,000s to get another bull or ox or whatever. So this is what technology has always done for us. It has always allowed us to produce more with less, or faster, or whatever, or cheaper. And so that's why the mantra that I have is better, faster, cheaper, and safer. Generally speaking, technologies, once they satisfy those 4 criteria, better, faster, cheaper, and safer, it becomes economically inevitable that it is adopted. In some respects, you could say it would be ethically required to adopt it, because here's an example. Let's say you go back, 2 centuries and you look at the way that medical procedures and surgeries were done, and it was, basically still the dark ages. They didn't really know anything about or not as much about anesthetics, and certainly not as much about hygiene. And once you can do it better, faster, cheaper, and safer with modern surgical tools, modern monitoring equipment, modern antibiotics and that stuff, you're ethically required to do it the new way.